chemical engineer by trade. Born and raised in Sudbury, Ontario. Anybody ever been there? No. Cold, but a deep-rooted history in mining. So when making the railway across Canada, some astute guy picked up a rock that had funny colors to it. I'm like, this is really heavy. I think there's some good stuff in there. That's how the Sudbury Basin got discovered in whenever the railway went through, 1830 something. So we've been mining there for over a century. I've spent my entire 30-year career with the company. Back then it was Inco, then we got bought out by Vale, a Brazilian company. Deep-rooted family history with the company I worked for. Both of my grandparents, my grandfathers, emigrated from Ukraine to work for the company. My dad worked 40 years for the company. I worked my whole career for the company. My kids are in nursing now, but anyway, they need to help people. But a deep, deep history in the community. My career started out in the technical group. I was an engineering student. Then I got hired into our process technology group. And I realized real quick, I don't really want to write reports that go in a filing cabinet. I like people, I like making decisions. So I chose an operations path. So I've held every level of operations, from shift boss, control room operator, general foreman when I managed multiple crews, superintendent, now I'm running a department, plant manager, now I'm running a facility, and then ultimately general manager of our refining business. So the vast majority of my career was spent in our refining business. We're going to talk about nickel carbonyl, fascinating stuff. In Sudbury, Ontario, we have the largest carbonyl refinery in the world, 64,000 tons per year of ultra-pure nickel. Operates at 1,000 pounds pressure, 1,000 PSI. Operates in the community, okay? Right embedded in the community. So do you think we had good protocols around safety, community awareness, emergency prep? Absolutely. And this is what we're bringing to the community of Lawton. What we know. Go save some people. Yeah, so I started with Westwin in March of 2023. My God, that's 2 years. Jogging on a frozen lake, minding my own business, and my phone rang. So I got a phone call, heard about the Westwin story, realizing there's not one nickel refinery in your country. Being Canadian, that's kind of odd. Biggest superpower in the world. This sounds like a cool project. So that was my motivation. I have a deep network of experts throughout my career. So I became part of a technical team that designed from first principles the pilot plant on Bishop Road that we started up and made first nickel on December 11th, 2024. That's really historic for us, for everybody. Yeah, so that's my background. Let's get into this. So, and please ask questions. So I already touched on this, total absence of U.S. domestic nickel refining. I mentioned that we've been mining for over a century in Sudbury, Ontario. The company is so rooted in the community. You can't, there's like 0.1 degree of separation when you go to a grocery store or a hockey arena. You know somebody from work. Everybody knows somebody that works for the company. There's liaison committees. There's sponsorships. Just the company is so rooted into the community. And this is something I'm really, really excited to bring here. I call it generational employment. So I'm third generation, and this is something that we can create here. The other thing that I like is called local. We've got 14 fantastic employees at the pilot plant, And I'm very proud that every single one of those employees is local. I call Duncan local. Jeannie, close enough?
Yes, right.
So we're supporting as much as we can the local talent here. So all of our 14 employees to date are local. We're going to talk a little bit about why nickel carbonyl, and you're going to learn that it is absolutely superior around the environmental footprint. There's no solid waste, there's no liquid waste. And it's a great investment. In case you're not familiar, Lee Avenue, this is Republic, Goodyear, 122nd?
112.
112, I knew I had a 2 in it. And this is where the pilot plant is located, right in this little tiny corner. That would be northeast. Future expansion, even though we have this entire 480 acre plot of land, is going to be in, north of where the pilot plant is. So in terms of proximity to the community, there's a cluster of homes here. They feel like we're in their backyard. Where we operated, we had communities here, 750 meters away. Metric. So very, very close to a community with churches, baseball fields, just rooted right in with the community. Now let's do some fun stuff. What is nickel carbonyl? So, elemental nickel loves carbon monoxide, loves it. So, in the absence of temperature, but lots of pressure, this wants to gobble up carbon monoxide to create a carbonyl molecule. So 1 nickel, 4 COs. And the beauty of this reaction is that you can go the other way. It's called reversible. So instead of cold, you go hot. Instead of lots of pressure, you don't add any pressure, atmospheric. And then this reaction goes this way. It's called decomposition. And Ludwig Mond, German guy, actually invented this in Wales, where the first carbonyl refinery was built and commissioned in 1902. The plant I ran was commissioned in 1972, okay? That's where that was developed. So that's the basis of this whole technology. So all we do is use the CO to react, and then that same CO gets decomposed and gets routed all the way back to the front of the bus. So you just got this big loop of CO going round and round and round and round. Okay? A little deeper in, what's our feed? We're currently using a mixed hydroxide precipitate. Okay? A hydroxide is an OH. So salt, NaOH. Nickel hydroxide, NiOH. So this is not local. We're purchasing this overseas. What we do with this material is we need to get rid of the OH as per the last slide. And how do we do that? We use reduction. Okay, so hydrogen takes away the OH, makes steam. Now you're left with elemental nickel. That's what enters the carbonyl circuit, and that's where there's no solid liquid or waste. There's lots of cats and dogs in here. You've got manganese, you've got magnesium, cobalt, iron. CO is very selective to nickel. Okay, that's the beauty of this reaction. So that's why we can make an ultra pure product. We're going to be making powders, and we're going to be compressing those powders to make briquettes. So, nickel powder, 99.9, arguably another 9 after that, % purity. We make different kinds of powders depending on how we decompose the carbonyl. gas strength. How strong is the carbonyl gas? The temperature in our decomposer, the flow rates. We can make all kinds of funky powders. Spherical, spiky, filamentary. I got a little slide I'll show you just to illustrate what these look like. Lots of cool applications, electronics, 3D printing, batteries, okay? Everyone knows about the whole upcoming EV revolution. What goes in those batteries? Lots of nickel, okay? So we are positioning ourselves for that hockey stick, as we call it in Canada, when demand gets, exponentially accelerated. Powder metallurgy. This is cool stuff. So you take a spiky powder and you compress the living bejeebers out of it, and you make parts, pure nickel parts. Then you make little chiclets, as I call them, into a briquette. Now what that allows you to do is feed a pyrometallurgical process, which involves furnaces. So now you're getting into super alloys, okay? Jet engines, etc. Stainless steel, that is the biggest usage of nickel on the planet, okay? Plating industry, aerospace. So we can play in all these markets. And depending on what market's stronger or weaker, obviously we're going to chase premiums, supply demand. I need lots of battery powder. Well, you know what? We're going to make more of that. Or, you know what? Superalloy business is booming. Well, maybe we'll make a little more of that. So we've got flexibility on our what we call product mix. Okay? No questions. There we go. This is under a scanning electron microscope, SEM as we call it. Here's our spiky or dendritic powders. These are different forms of filamentary powders for batteries. It's really cool when you add just a smidgen of oxygen when you get these really long filaments. So it's fun stuff to play with. When you look at the reagents, okay, it's not a lot. You don't see the sulfuric acids and the ammonias and all that nasty stuff. We add a binder because we actually briquette our MHP, and that goes into a kiln that's fed with hydrogen to do that reduction that I spoke about earlier. Sodium silicate, very benign material. Carbonyl, CO. There's your reagent. I could count it on one finger. And when you, to be determined, because I'm not sure we need this, but if we do, the binder's starch, which you can eat. We do use a lot of what we call IG, inert gas, for purging. Okay, purging. That doesn't react, so that's not officially a reagent, but we do use a lot of nitrogen. So, worth mentioning. Demonstration plant flow diagram. Very high level, obviously. MHP goes into a feed bin. Feed drops in a reaction vessel. CO goes into the vessel, reacts with the nickel, creates nickel carbonyl, gets stored, condensed, goes through some magic here, and then gets decomposed. Okay? Unreacted material goes into a residue bin. We're just going to sell it. Bag it, sell it. Lots of people like that stuff. Lots of good payable metals in here, manganese and cobalt in particular. Some iron and a tiny bit of cobalt may carbonylate, also react. So this step removes any of that material, and we produce, not yet, but we have the ability to produce an alloy powder. And then this product is bagged or drummed and sold to market. So that's what the pilot plant looks like, or demonstration plant. The commercial plant will be similar, but much larger, which we're heavily into design mode. So I gotta tell you all of the aspects of nickel carbonyl. Nickel carbonyl can kill you, okay? It's no joke. This stuff is extremely lethal. How lethal is it? So, this is called the EPA's AEGL, Acute Exposure Guideline. So, a 3 means irreversible, you're in bad shape, you need a hospital. 2 means you're medically impacted, but is reversible, okay? So, if you look at this axis, you notice PP, what does the B stand for? Parts per billion. You've heard of ppm, parts per million? This is parts per billion, okay? Add a whole bunch of zeros on that. So this is the exposure durations, and obviously the higher the exposure, the shorter the duration. IDLH, immediate effect to life and health is 2,000 ppb, okay? So just to put this into a little more perspective, let's just focus on that 8-hour bar. Okay, so I've blown that up, changed this axis. We have incredibly sensitive analyzers that can detect, I kid you not, nickel carbonyl even less than 1 part per billion. Okay, that's how sensitive these pieces of equipment are. So the way our plant operates, if you have a leak, we call them punches. We get a punch on our analyzer. It'll start at 1 ppb. Okay, so now we know something's going on, and we're going to try to find out where it is because we have pickup points, different areas of the plant. Should it get to 4 ppb, lights and horns. Okay, what does lights and horns mean? That means operations people, control room, positively pressured, safe place. Non-operating people, muster, evacuate. Okay, and then we make a plan on dealing with the leak under SCBA. I don't need to tell you guys what SCBA means. So that is the level of sensitivity that these analyzers are capable of. Questions? Okay. What happens when we have a release? I talked about the 4 parts per billion. Talked about non-operating people evacuating, finding the leak with SCBA. Here's a really important fun fact. It's not a fun fact, it's a fact. Remember I said nickel loves CO? When it's a carbonyl molecule, it hates oxygen. It hates air. So it readily decomposes. And the hotter the ambient conditions, and I've been here in the summer, hottest I've ever experienced in my life, kid you not, it'll decompose like that. What is 44 degrees C? I'm just curious, because that's what it was, and I could not believe how hot it was. But at any rate, I digress. So this will very readily decompose well before it would breach our boundary, okay? So there's no need for panic in the community. There's no need for a response. It will decompose. We will find the leak. We will contain the leak. And there's lots of proceduralization around how we do that. Fire or explosion. This is a really, really dicey one. There's lots of different kinds of fires, as you know. So if we have a electrical fire, something to do with natural gas, we have a fire suppression system within the plant. The plant I ran, the largest carbonyl refinery in the world, was not sprinkled. Why was it not sprinkled? Well, the specific gravity of nickel carbonyl is 1.3. Water is 1. What happens when carbonyl liquid goes into a pool of water? It sinks. Okay? What do you think? So is liquid carbonyl flammable? Yes, it is. But a carbonyl fire is a very lazy fire. It's kind of like almost like pretending you're at a fondue and you got that little Bunsen burner thing and it's just kind of slowly keeping the pot warm. That's what a carbonyl fire is like. So what's going to happen if you throw a bunch of water on this thing? Fire goes away. Does the carbonyl go away? Nope. So we feel very strongly to not sprinkle a carbonyl facility for that very reason. And there's members, at least one on my team, that has a personal experience. Exactly that happened. Fire went out, went to clean up, fire comes back. And then it comes back again because you're disrupting the water and carbonyl likes to flow. It's nasty stuff. The best thing to do is to let it burn. And I gotta put a big asterisk when I say let it burn because I learned this the first attempt to not sprinkle at the older fire station. Their view of let it burn was let the place burn down. No, that's not what I'm saying. I'm saying let the carbonyl extinguish itself. Let it burn, monitor it. You know, if things start getting out of hand, yeah, we might give you guys a call. But if it's in a controlled area and it's not escalating, you let it burn. To put one more thing into perspective here, in my entire career, I have never seen a carbonyl fire. I've seen lots of liquid carbonyl, but I have never experienced a fire. So this is an extremely rare situation. It's not like this happens every 6 months, year, 5 years. So very, very extremely rare. Any questions about that? Kind of interesting, isn't it, to let a fire burn? Exposure to carbon monoxide or nickel carbonyl. What happens if you're exposed? You think you're getting a cold, or I'm coming down with a flu, I'm coming down with something. Because what's actually happening is when you inhale nickel carbonyl, remember that reversible reaction? It's what's happening in your lungs. So you feel like you're coming down with a cold. The way your body gets rid of nickel is it breaks it down and goes through your urine. So to measure the level of exposure, we analyze urine with an AA machine. Micrograms per liter, that's a ppb, okay? All employees get what's called a baseline. Everybody's baseline is different. If you're a smoker, if you eat seafood like a champ like me, it'll be a little bit higher. Everybody's is a little bit different. So when, in the event of an exposure or a potential exposure, we now have the threshold of your normal and your normal and your normal to determine the actual level of exposure. What if you have been excessively exposed? So we have a very, very strict treatment protocol depending on what that microgram per liter number is, okay? We have an antidote. It's called Antabuse. That's the aspirin version name. It's actually a chemical, but it's Antabuse, and they actually treat alcoholics with this because if you take it and drink alcohol, you get violently ill. But what is Antabuse? It's what's called a chelating agent. Okay, so it goes after that nickel in your body and attaches to it and accelerates the rate of your body's ability to dispose of the nickel. And it works. We've had, we will have exposures, but we know how to deal with exposures. So let me, I get choked up every time. This next bullet was a guy named Brian. Brian showed up with a cold. Overtime shift. Typical. Weekend. Felt under the weather. Coming to work, okay? They were doing a risky, but well-proceduralized liquid drain. Won't go into the details of what it involves, but you're actually outside, and you're draining liquid back to a safe storage area. And he had a cold, and he's dealing with liquid carbonyl. He pulled his mask off to scratch his nose, put his mask back on, not knowing that a droplet of nickel carbonyl was on his glove. He breathed in all that nickel carbonyl, went home. Got worse, couldn't shake this cold, couldn't shake the flu, just got worse and worse. Finally, something's going on here. By the time he got to the hospital, it was too late. That was a bad day. So I was on the task force. So simple. So simple. All we needed to do was send a taxi to his house. Brian would pee in a bottle. We'd bring it back to the plant, run his AA. You've been exposed. You need antabuse. He'd still be here today. We call that the absentee protocol. If you call in sick because you have a cold and you work at that carbonyl refinery, you're getting a taxi to your door. You're going to pee in a bottle, and we're going to analyze it as a precaution. Absentee protocol, okay? We learned a lot of things over the 50 years, and that's probably the biggest learning, certainly in my career, because I will never let that happen to anybody ever again. So when I say precautionary protocols, there are precautionary protocols. We have trained lab technicians. They will run the AA. And if you require, so there's a procedure, you take it immediately, then if it's elevated to a certain point, we take, it's called an 8-hour sample. And at whatever stage we determine you need medical treatment, we send you to Comanche Medical Center. We've had, Dr. Meek's been incredible. So he runs the occupational medicine department, and we've had several meetings with him. His staff are aware, the emergency room staff are aware. Because what's important is the medical community needs to know the symptoms, okay? So every employee, we're cookie cutting what we know and what works. We have cards, medical cards. They tell you where you work. They tell you what the potential exposure is. They tell you what the symptoms are. So if a doctor's not sure, the employee can provide this. Because this is not prevalent everywhere in the world. This is a very unique technology. I didn't mention this earlier, but there's, I think, less than 10 carbonyl refineries in the world, okay? So yes, we will test on site, and we will invoke whatever protocols are required, which may include Dr. Meek's department or the ER. They have 1,200 tablets of antabuse.
I don't want to keep asking questions if you're going to get to it, but is the test any good without a baseline?
Oh yeah. I mean, your baseline would be somewhere like 8.
Okay, so
I'm just guessing. Or yours might be 12, or mine might be 16. But if your analysis is 800, I don't care what your baseline is, you're going.
It's that big.
Yeah, oh, yeah. Yeah, I think the number's 1,200 where anti-abuse kicks in, if I'm not mistaken. Don't quote me on that.
What's the time on the anti-use and where it's affecting the life?
It depends. It depends. So if you have like a moderate exposure, days, like not long. You know, you might take a tablet right away. You might take a tablet the next day and we retest you, and that's typically what would play out unless there was some kind of, major issue. Good questions.
Is Southwestern Hospital aware?
I don't know. That's a great question, Lisa.
I haven't worked with them at all.
No.
Our protocol is to go to Comanche because that's where all of the testing has been. The baseline testing was actually done through Dr. Meeks' office and came back to Dr. Meeks. So all of that is enclosed at Comanche. So it's not that you couldn't go there, but they're going to probably.
So here's my broader answer. No, for now. Because we have 14 employees and this is brand new. So we've worked with Dr. Meek's team and the Comanche, and our employees have gone there. They've done their screening, they've done their fit testing, they've done their baselining. So that's our focal point right now. When we commercialize, which we're well underway to design and construct, but guaranteed we're going to engage the entire medical community. Yeah, thank you. That's a good point.
So if it comes to just a true medical emergency without any of this being involved, if they truly need treatment, our protocol is to go straight to the closest appropriate facility. Which say if it's a cardiac arrest or something trauma, we're right around the corner from Southwestern.
Gotcha.
But I think what you're getting at is if it is an exposure or something along that lines, we're going to follow the protocols to the most appropriate facility. So we're going to Comanche with that.
I guess I meant like if one of us was exposed, I personally use Southwestern, and I went to them having these symptoms, if they were aware of.
Yeah, I'm trying to figure out why you would be exposed, because.
Just if we happen to go there for whatever reason.
Okay, let's just pretend that's the case. Then by that time, with commercialization, we would have the protocols that we have with Dr. Meek's team with that hospital as well. If that answers your question. Yeah. Okay. No, thanks. Excellent. So deeper into controls, ventilation is very, very important in a carbonyl facility. We want multiple air exchanges, okay? Minimum of, say, 6, targeting 8 air exchanges per hour. And carbonyl is heavier than air, so it will sink. So air comes in at the top, air goes out at the bottom, okay? So we have pickup points, I mentioned that earlier, throughout the plant. But if something sneak by a pickup point, it will enter the exhaust system, where we will also monitor for the presence of carbonyl. The other control is CO. So CO is what we call a carrier. This is a CO monitor, probably familiar with these. Every employee carries a CO monitor. So can we have a CO leak? Yes. But what's more prevalent is a carbonyl leak will decompose, and now you'll have CO in the environment. So we also have fixed CO monitors, and every employee carries their own personal CO monitor. So in addition, kind of talked about that, emergency showers, first aid kits, and we talked about the Comanche the Comanche Hospital as well. All right. That's all I got. Question?
When that's done, how is it transported out of that facility?
The nickel? In a super sack, we call them. It's an industrial standard kind of industrial bag. Yeah. Are you talking pilot plant?
Yeah.
Oh God, this is small. Yeah, like we're not really selling anything out of this plant. We're proving the technology, we're proving the purity, we're certifying it, and we're getting what we call offtake agreements for our product when we commercialize. So this is a training ground. This is to prove the product quality that we can make, kind of R&D. This is not a commercial facility. The commercial plant, on the other hand,
But that's what we're looking for, one is a commercial plant.
correct. Yeah, so,
It comes in powder or briquette form.
oh, they want you to talk into this.
Oh, God, no.
Don't you love when people shove microphones in your
No, I
face?
don't need that. They know I
Check
don't
one,
need
two,
that.
two. Sorry, I'm a musician as well, so,
All right, like that.
yeah.
I'm just wondering what the hazards are. Once it's commercial property, or commercial, they're selling it, it's coming in and out of this town.
Yeah, so,
That's what we live in.
yeah,
If it comes out and catches on fire on Lee Boulevard.
it will not.
Not
So,
that-
so nickel, getting into more details, but I like it.
Yeah.
Nickel powder is called pyrophoric, so it'll self-heat.
Right.
So we
I'm looking at-
passivate it with a mixed gas to take out any static so that it doesn't self-heat, but it will not burn. Nickel powder will not burn. MHP will not burn. So fire is not a hazard. I'm trying to think of the worst hazard. I mean, you spill a bunch of MHP on the ground. So the raw MHP, the way I describe it, it's 50% moisture. It's very, very hydrophilic, likes water. Picture, when you're playing with your kids on the beach and you're making a sandcastle, that kind of saturated sand. That's the raw MHP. Yeah. And our anticipated form of receiving at commercial is containerizing it. So when I say connexes, you call them here, I call them containers, but basically the containers that go on cargo ships, transports. Yeah. So we're in the order of somewhere around 8 a day, 8 containers a day for commercial. So a lot of concern in the community around truck traffic. It's 8. And then out the door is less than that. It's a number less than 8. Yeah. But nickel, if there's a nickel spill, that's a different story.
That's what I'm wondering about.
Well, you would call industrial cleaners, and they would suck it up. You can't just leave that. Like MHP is pretty benign stuff. Sure, you'd clean it up, but it's not to the extent that you would with pure nickel powder. Even in the plant, we have basically an industrial central vac system. All the nickel, there's no water. You basically vacuum it. You suck it up.
And that's the finished product, is the MHP,
That's the raw material.
the raw material.
Yeah.
So the finished product
Is nickel.
Carbonyl, right?
Finished product is nickel. Carbonyl is how you extract the nickel.
Right, okay.
Yeah.
Where
Cool.
do you get nickel carbonyl from?
When you take the MHP
And you get
and you reduce it to make elemental nickel, and you remember the pressure and no
Yeah.
temperature,
Yeah.
that's how you get the carbonyl. Whoop, that guy right there. That's how you get the carbonyl in that reaction vessel. Okay? And then where does the pure nickel come from?
So if that
You just go the other way.
If that catches on fire, at what stage?
This can catch on fire in liquid form only.
Which
Yes.
you will deal with at that point.
Oh, yeah.
That's what I'm saying.
Liquid is no joke. We are,
You can't touch it. it catches on fire at room temperature.
No, it doesn't catch on fire at room temperature. It is a funny thing on how it's typically static.
But its LEL's 2%, and then its
Ooh.
and its upper is.
How did you know that? That's good.
Because that's my job.
That's good for you. Good, excellent.
We're hazmat techs.
Yeah, so LEL is carbonyl in air is 2%.
It's ready to go.
So it's how we deal with carbonyl is very, very strictly adhered to procedures. That's where the IG, that's where the nitrogen comes from. So there's a whole purging philosophy. Get the carb out with CO. Get the CO out with IG. Get the IG out with air. Now you could safely work on a piece of equipment. And now you do the reverse when you want to put it back in service. Right? Get the air out with IG. You never want to mix O2 and carb. We call it carb, nickel carbonyl. So things going under vacuum, problem. Air ingress. So we have vacuum breakers. We have all that designed so that we do not have air infiltration into our process piping and equipment. And CO, I'm trying to remember, 12 point something to 72 is the range, LEL range, I think 12.4. But it's ish in that range. So CO has another very broad explosive range. So that's another thing we take very seriously. Really good questions. No, thanks. Any other questions?
On your full-scale plants, what's like your most common hazard that happens, I won't say frequently, that
You're probably gonna think I'm making this up. People interacting with mobile equipment. That's my answer. The carb is so strictly adhered to that, you know, when I think about personal harm or critical injuries or lost time injuries or hospitalizations, people and moving equipment. That's my answer. We got the working at heights thing pretty good. Yeah, everybody takes that quite seriously. Being tied off, LOTO, lockout, tagout, zero energy, you know, confined spaces. That stuff is really tightly controlled. It's when people just wander off and don't pay attention. And buddy's on a forklift, thinking about the hockey game last night, and then problem. Or when he's going to snuff the next moose. But excellent question, yeah. When I do that, what I call, you know, manage by walking around, and that's funny. That's one of my, I have two questions, you know, what's pissing you off these days? But the other one is, where's our next injury going to happen? And I'm telling you, 9 times out of 10, we need to reroute this forklift traffic. I've seen so many near misses. Oh, okay, well, let's get the team together. Let's fix this. How about we do that right now? You know, that's the kind of culture I want to create here. And we got a great team there. Oh, I'm excited to get to the next steps.
what's your, I know you said 14 here, a full plant scale size, what's the employee, how many employees are?
Jeannie, what am I supposed to say to this question?
Well, of course, I want you to be honest.
I know. It's tongue-in-cheek because this number is, anyways, approximately 150 people.
Cool.
Yeah.
So our first phase, commercial, that we are moving toward will be a total of about 200 people, maybe about 150 here in Lawton. But that is just the beginning to scale up. And a lot of that scale up does depend on the product that we sell and the volume.
Yeah. Yeah, our plan is to have multiple phases of expansion. Carbonyl refineries are what we call trains. So when you do decomposition, you have a train of decomposers. You know, you got a train of a reactor circuit. So just add more reactors, add more decomposers, you can now expand your capacity. All right? Oh, yes, please.
So
Yeah.
the carb, as you call it, never leaves the nickel carbonyl. That never leaves the plant.
That's what we endeavor to do.
Right.
Every day,
It's there.
all day, that it is contained.
See, that's what I was under the impression like that's what the product is, and it'll be running up and down the.
No. Good. I'm very glad you're
That's
bringing this up.
That's what a lot of firemen. think.
Well, that's why I'm here. So you need to tell your friends that this is not the product. This is just a vehicle to go from that this way to that under these conditions, and then from that this way under these conditions. This is a decomposer is basically a tin can with heating elements. You have 4 zones, and the temperature grade or profile helps you make different kinds of. It's like a little snowstorm in there of powder raining down. So we keep the gas cool. As soon as it goes into the decomposer, it starts to heat up. So there's no pressure at this point, but there's no heat also. So as soon as you add the heat, decomposes in this tin can, gets collected at the bottom, purge it clean, purging thing I talked about, and then you dump it into a sack. This is actually simple. It's everything about it that's not simple. I failed miserably at retiring, if you haven't noticed, but I'm having a blast doing this. I feel like I'm part of the community. I used to come out of my apartment at Flats of MacArthur, and where my apartment is, I look at Mount Scott every morning, and what am I doing here? A boy from Northern Ontario, but I don't do that anymore. It's feeling like I'm, part of the community and happy to be here. Yeah, the more questions you have and the more facts you've got, the better it's going to be for the community. So, all right, thank you.